Hi everyone, welcome to today's video. So this is our second lesson on algebra in our GCSE Maths Foundation course. So we're going to be looking at factorising and a concept called difference of two squares. So first of all, why would you want to factorise an equation? So firstly, it makes the equation a lot simpler. It makes it a lot easier to work with. It allows you to identify things like common factors, so you can break down and simplify your equation further. But the main reason is it's going to help us in solving the equation. So in later lessons, when we're looking at actually solving our algebraic terms, so when we're finding values for our letter terms, simplifying down and putting brackets in is going to help us in finding those answers a lot quicker. There's a process for factorising. The first thing we're going to do is we're going to look at finding a common factor for our number terms in the equation. Then for each letter, so we're going to take out the highest term that goes into every letter term in the equation. We're going to put a bracket in, and then we're going to divide each number by the factor to fill in the bracket. So this may look a bit confusing at first, but it will become a lot simpler as we go through our examples in the next couple of slides. So we're going to have a look at this question now. Factorise the following: 9y plus 15. So the first thing we're going to do is we're going to look for a common factor for our number terms. So we're going to look at the 9 and the 15 here. And we're going to see that a common factor is 3. And that's because 3 is the largest number that goes into 9 and 15 that still results in a whole number at the end of it. Then we're going to look at our highest power letter term. So the highest power letter term we have is y. So that's not going to factor into our common factor because y doesn't appear in both of our terms in the equation. You can see that we've only got one y here. It's not anything to do with the 15, so we can't take a y out as a common factor. So we've got a common factor now of 3, so we're going to put our brackets in. Our common factor is going to sit outside the bracket. So now we have to work on filling in our bracket. So the first thing we're going to do is we're going to divide 9y by 3, so our common factor. So 9y divided by 3 gives us 3y. That's the first term in our bracket. Then we're going to do the same thing for our 15. So we're going to do 15 divided by our common factor of 3. So that's going to give us 15 divided by 3, which gives us 5. And that's the other term in our bracket. So this is our answer here. So this is the answer to factorise the following: 9y plus 15. And we can prove that our answer is correct by simply reversing the process. So we got the answer of 3 times 3y plus 5. And we're going to multiply out the bracket. So multiply everything on the outside with everything on the inside. So we're going to do 3 times 3y to give us 9y. 3 times 5 to give us 15. We'll put it all together to give us 9y plus 15. And you can see that we've got back to our original question. So our original question of factorise 9y plus 15. That's why we've ended up by multiplying out our factorised answer. So example 2 now. Factorise the following: 6x squared plus 8x. So first thing we're going to do is we're going to look for our common factor for our number terms. So we're going to look at the 6 and the 8. So our common factor for these two is 2, because 2 is the highest number that goes into both 6 and 8, that when we divide by, we still get a whole number at the end. Then we're going to look at the highest power that goes into both terms. So both of our letter terms. So we've got an x squared here. We've got an x. So we're going to look if there's a common factor between our letter terms. And there is. So there's a common factor of x because x goes into x squared and leaves us with a whole number, and x goes into x and leaves us with a whole number. So we've got another common factor of x here. So our combined common factor is 2x. So 2 from our number terms and x from our letter terms. So we're going to go ahead and open our bracket now. So we've opened our bracket, so we've got 2x and then our bracket. And now we've got to fill in our bracket just like we did in our previous question. So the first thing we're going to do is we're going to do 6x squared divided by 2x, which gives us 3x. And then 8x divided by 2x to give us 4. And that fills in the second part of our bracket. So this is the answer to this question here. So this is the factorised version of this equation. And like we did previously, we can prove that our answer is correct by simply reversing the process. So we got the answer of 2x times 3x plus 4. So we're going to multiply out the bracket. So let's multiply everything on the inside with everything on the outside. So we're going to do 2x times 3x to give us 6x squared. 2x times 4 to give us 8x. Put it all together to give us 6x squared plus 8x. And you can see that takes us back to our original question of factorise 6x squared plus 8x. So we know our factorisation is correct because we've not lost any value between factorising it and the original question. Right, so now we're going to look at our next concept: difference of two squares. So difference of two squares is a special case scenario where we can very quickly factorise an equation if it meets this rule of one thing squared minus another thing squared. So this is the rule down here: a squared minus b squared equals a plus b a minus b. So we have to have our original equation in this kind of format, a square number minus another square number. So if we look at this example, factorize the following: f squared minus 4. So the first thing we're going to do is we're going to check if our expression meets the difference of two squares condition. So this is our question, f squared minus 4, and this is the condition it has to meet, a squared minus b squared. So we're going to check if the first number, so this f squared, but we're going to check if it's a square number. Of course, f squared is a square number because f squared is equal to f times f. Now we're going to check if there's a minus between the two. So see there's a subtract or a minus here. So we have to check that that's present, which it is. And then we check if our second number is also a square number. So our second number is 4. So we're going to check if 4 is a square number. Of course it is, because 4 equals 2 times 2. And then that's how we know that our original question meets the conditions for difference of two squares. So now we can just apply our difference of two squares rule, which is a squared minus b squared is equal to a plus b times a minus b. So when we apply that rule to the equation, we get f squared minus 4, our original question, is equal to f plus 2, f minus 2. So you can see it's the root of both of these numbers that goes into the bracket. It's the root of f squared that goes in here. So the root of f squared is f, and the root of 4 is 2. So that's what goes in there. And you can do the same thing as we did previously. We can multiply this back out, and that will bring us back to f squared minus 4. If you're not sure how to multiply out a double bracket, look back at lesson 13, because we did an example where we worked through multiplying out a double bracket like this. Okay, so one more question on factorizing. So here we've got factorize the following: 25m squared minus 1. And we can do the same thing first. We're going to check if our expression meets the difference of two squares condition. So we're going to look at our first number. So is our first number a square number? So this 25m squared. Of course, we know that it is, because 25m squared is equal to 5m times 5m. So the 5's multiplied together give us 25, and the m's multiplied together give us m squared. We're going to check if there's a subtract between the two numbers. There is. And we're going to check if the second number, i.e. this 1, is also a square number. 1, of course, is a square number because 1 times 1 gives us 1, so 1 is a square number. And then we can go ahead and apply our difference of two squares rule like we did in the previous slide. So 25m squared minus 1 becomes 5m plus 1 times 5m minus 1. So you can see we've got the root of this a term here, and we've got the root of the 1 here. And again, if you went ahead and you multiplied out the double bracket, you would see that you'd end up back at the original question here. So that's it for today's lesson, guys. A quick one on factorizing and a new rule called difference of two squares. So these couple of techniques will help us a lot when it comes to especially solving our algebraic equations. So check back again next week for our next lesson. Thank you very much.